Welcome to the Level Design Podcast. In this episode, we go inside the mind of the NPCs of the games you love with the help of Tommy Thompson. Let's get on with the show. Hello, and welcome to this episode of the Level Design Podcast. I am joined by my wonderful co-host, Rob McLaughlin.
Hello there.
From the lovely Chinese room, and Valentina Chrysostomou. Valentina has joined me in Command Studio. We're going to be breaking games and making games and...
Mostly breaking them.
Mostly breaking them. I think we've already raised 15 bugs on...
There's more bugs than actual features, so that's perfect.
Right.
That's how it works.
So we're like on day 3 or something, and we've already created more bugs than anything. So welcome, Valentina. And of course, the voice that's behind the AI, that's behind the games that you love, the wonderful Tommy Thompson. Welcome to the show.
Hello, thank you very much for having me. That was also a very nice introduction. But the voice of the AI, I now feel like I'm overselling myself somewhat.
Yeah, you're Holly. You're basically, now you have to like do all the voices for all the different AIs in all the shows that we love.
I mean, that'd be a steady paycheck. I wouldn't say no to that.
Right. Red Dwarf, let's get rid of Holly. Here comes Tommy. For the audience out there that don't really know your body of work, I think I can say that you're known not for the thing that you've worked hardest at in your life, right?
Yeah, it's kind of weird how my career, or if you want to call it that, has sort of changed or evolved in the last 5-6 years to a point that most people don't know me for where I actually start from. So to quickly give a kind of like me in 90 seconds, I actually come from a background in academia. I worked as a university lecturer predominantly in computer science, and then more recently focusing on game development. But I have a research background in artificial intelligence applied to video games. I have a PhD in that subject area. I published 40-something.
So you are Dr. Thompson?
Yes, Dr. Thompson. Mm. It's got to that point where the back of my name has now more titles on it than my name itself, which is kind of ridiculous. So it makes me look really good on paper, and then when people meet me in real life, they're like, "Oh no, I take everything back. He seems like a bit of a muppet."
Oh, I doubt it.
You're only saying that because you've met me in person. And yes, so about 5-6 years ago, I started a YouTube series called AI in Games, which is about artificial intelligence in video games, which I don't know. It was just something I really wanted to do and kind of really expand out into a different direction. And now most people just know me as that Scottish guy on YouTube than anything else that I actually do. And I still do a lot of other bits and bobs like behind the scenes as well.
And that's kind of how I got introduced to you, because you made a video about a game that I think I can say that most of the people here on this podcast, and I'm sure most of our listeners love a lot, is Alien Isolation. And you really got into the mind of the xenomorph and kind of showed the tricks that they were doing, and then expanded that series into like all the other games. Is that the order, or?
So it's the episode that people know the show for, and it's the episode that made the show successful. I think, if I remember right, Alien Isolation is episode 15.
Okay, right. So you'd been doing it for a while. But...
I'd been doing it for about 3 years. But 2.5 years, actually, I think, when Alien was done. Episode 15, if I remember right. Before that, I'd looked at Left 4 Dead, Fear, Batman Arkham Asylum, a couple other games.
Okay, so I've just seen them out of order then.
Oh, that's fine, because everyone knows that one. And it's interesting because, so I've been doing this now for about 6 years, and I consider the channel has had 2 epochs. There is everything before January 2017 and everything since, because January 2017, that Alien video bounced around on Reddit, and my channel went from being completely obscure to, oh hey, like people are now watching this and watching this a lot. And essentially, I think I had 3,000 subscribers in my first 3 years, and in the last 3 years I've then had another 120 something thousand. And essentially, yeah, everything can be attributed to that first Alien video.
Just takes one video.
Yeah.
Yep. Just somebody liking something and sharing it somewhere.
Did you release that video after the game was released, or what was the timeline for it?
The video came out in August of 2016, so it would have been about roughly 2 years or a year and a bit, actually. Yeah, a year and a bit since the game had came out. And that's kind of how most of my videos work, because a lot of what I do is digging into the inner workings of an AI system in a game. You know, I usually pull from like GDC interviews or talks and like research papers that are published and stuff like that. And it's very difficult to do that around the time a game comes out, because those talks haven't happened. They still want to keep quiet about the inner workings of the development of that game. So usually about a year or so after a game comes out, then all the research materials that I need that I can make an episode then start to like crop up on the internet, and I can start seriously considering whether or not I can actually make a video about it.
Because that's a really good show for game developers. You know, it's kind of, I love the way that you've been able to get in there, and I've learned so much from it, especially the camera on the tail of the alien, so you can't step on its tail. Is it a camera or is a probe?
Yeah. So it's got a raycast that runs off the back of its head onto its tail. That's also an interesting fact, because it's the first genuine exclusive the channel ever had. That's not in any talk that was ever given. So the original video is actually based on a talk that was held at the Nuclei conference by Andy Bray, who was an engineer on Creative Assembly on Alien Isolation. But I had played the game and completed it by that point, and we were at the social drinks or whatever after that day of the conference, and I got chatting with Andy, and I said, I've got to ask, what's the situation with the tail? Because, and I get so much flack for this online, there's so many people in the comments who call me out, and people said, oh yeah, there must be like proper physics sensors embedded in the tail that it recognizes when it lashes off with it, when it lashes against an object or surface. And I said, how do you do it? And he just kind of spat on his beer like, oh, no, we just run a raycast from the back of the head to the tail. It saves us so much hassle, and it guarantees the player can't walk behind you. And I was like, oh my God. And like, I'm slightly inebriated at this point, getting my phone out, like, make a note of this. This needs to be in the video. And so, yeah, like, subsequently, I've seen that fact get bounced around on the internet a lot. And it's like, that's me. That's mine.
It's very interesting how gamers think that, oh, this must have an intricate system behind it, everything works together so well, and the developers just hacking quickly something behind it the last minute before release, and it just works. Sometimes, like, you can see that a lot with game systems and big games.
Yeah, like, I think a lot of the time, for one thing, that's one of the reasons I'm quite interested in this as well, is that because given I come from a classical AI background, if you will, the difference between game AI versus actual AI most of the time is usually quite different, because one of the big changes is that AI for non-player characters in video games is all about, I think of it as sort of dramatic theatre. It's all about establishing a performance to make a character look like it's intelligent, to make it look and sound interesting. And if you need to hack that, if you need to employ any smoke and mirrors in order to make that work, then you do it. And it's really interesting, the longer I've done this, some of the weirdest hacks that are in these games, where it's just, oh yeah, we just enable this or disable that, or we make sure that all characters know this particular piece of information, because it just, ultimately, when it comes down to it, it sells that performance, and players don't notice it most of the time.
And it can be often a lot cheaper to calculate that, something like that, rather than running through a massive long behavior tree. You just have something really, really simple, just a simple check, and then early out from there.
Yeah, and a lot of things that people don't realize, for example, when a character AI just suddenly comes up from behind you, is they don't actually walk there. Sometimes you just teleport them right out of the camera view, and then you play the whatever animation, or just enable something in the combat system, and it happens. It's not like they were smart enough to maybe flank you. I'm pretty sure AI has evolved to be that, but sometimes when you want a scripted event, you'll just teleport them and tell them to play something specific, and it just does it.
I mean, good examples of that are, I guess, Ellie in The Last of Us and Elizabeth in Bioshock Infinite, right? They're always there, just off your peripheral vision, ready to throw ammo at you. Or...
I was trying to remember. So Elizabeth teleports periodically. Ellie can only teleport in one specific situation. In fact, that was last week's episode. I did the AI of The Last of Us.
Interesting.
Cool.
One of the interesting things about both Ellie and Elizabeth is that they're being given objectives on where to be in the world based on what's happening around the player. Elizabeth from Bioshock Infinite, she uses a principle of theatrical blocking as well as goal side, which you can take from like soccer, football, or American football. This idea of being somewhere between your opponent and the goal. And so Elizabeth, her job at all times is to find places on what they call the golden path, It's a path through the world that is calculated based on where you are and where you're supposed to be going. And she will always try and move into interesting places because the whole idea for that character is she's been, spoiler alert slightly, she's been trapped in the tower for her whole life. She has no idea of the wider world. So she's eating, candy floss and getting excited about it. She actually has an emotion in her behavior system for candy floss, which I thought was hilarious.
It's a candy floss subroutine.
There is actually it's a dedicated emotion for her, which then has a set of corresponding animations and stuff like that. So she'll always find stuff to do on the way to where you're supposed to be going, because it helps humanize her and make you empathetic towards her and what she's been through. But she'll frequently teleport outside of your field of view. If you turn from one direction to another, she'll quickly teleport just around a corner or something and then reappear. But they'll do it cleverly so that you never really notice it. Ellie's an interesting one because she always has to stay relative to Joel in The Last of Us. And what she does is they actually calculate a path, a region, imagine a pizza slice behind Joel's body. At all times, and what it does is it then runs a bunch of raycasts on valid points on the navigation mesh behind Joel to find areas that would make sense for her to be behind him, but she's not going to walk into a wall. Or if he's walking down path B, she doesn't accidentally walk down path A while she's trying to follow him. So it's actually this really complicated bit of math they have to do just to make sure that she stays behind you, and she stays behind you in some realistic valid way. And it's one of those things that sadly can break all too easily. And then it's one of these things, it happens, and it's funny how players immediately express their emotions about these things, shall we say, very, very quickly.
It's kind of funny because we think of AI always as like a character in game and like the person in game, but I think from the Aliens video, and I know we're going back to it because that's the one I think I've watched the most, but there is kind of different layers. You've got like someone that's managing the whole stage and telling where people should be at, and the NPCs themselves. So we've got like different layers, and you've even worked on a game that uses AI to create the levels, right?
Yes. I mean, essentially procedural generation is to varying levels of degree is a form of AI. I would always argue that because it's an intelligent system making decisions about the placement of objects in order to create something. I mean, one of the things that I think really interesting about procedural generation, and there's a whole research field dedicated to this, is that you have no clear end goal. And even if you do have an end goal in a functional level, there is also non-functional or like aesthetic requirements. So you can make a level that is technically playable. You can make a level that is technically valid, but what makes that level interesting? What makes that level fun? What makes that level hard? Can you find ways to quantify that? Do you even want to quantify that? Like, quantifying fun is one of those things that really gets my heckles up every time I hear it. We've developed an equation that will allow us to scale fun between 0 and 1. And then we're going to ask a bunch of people how closely their metric of 0 to 1 is to our... Like, no, you're talking nonsense. Shut up.
No, that's machine learning, a completely different thing. It's like you put in a whole bunch of fun.
But that's something that's happening now, is machine learning can be used for procedural generation. In fact, I did an episode about this last year about some research in academia around Super Mario Brothers. I think it was episode 39 of the show. Where it's what happens if you start using machine learning systems that are fed Mario levels as corpus of their data, and then say, okay, can you generate new levels based on what you've learned from looking at other Mario levels? And there's some really fun stuff that's came out of that, where some of it's like nearly there. It's like it's not quite.
Right.
And then other times it's either completely off, or it builds something that you think, oh, that actually kind of looks like a Mario level. But it's required a huge amount of computation to essentially process every Mario level from the original Super Mario Brothers in order to come up with this largely semi-complete level that it's created.
Are they processing the levels or only players?
So you can do it both ways. You can read in just the raw tile set, which quite a few research projects have done that, where it's, okay, let's just feed in all of the original tiles and we'll try and kind of establish what the entropy, like spatial relationships are maybe, or the kind of common rules are within the levels, within the level design, which is sort of an evolution of some existing research on sort of level design patterns and how they can be exhibited within Mario levels and other games. But academia really loves Mario. It's nice and easy to understand and often easy to make.
Nice and clear.
Yeah, it's nice and easily readable. And everyone knows what Mario is now, for the most part. There's some work that's looked at actually modelling player behaviour as well. So if you can replicate or reproduce parts of the player's performance, can you use that as a metric by which to assess the quality of the level? So I can generate a level so in fact there was a research competition back in 2010, which was the first ever Mario level generation competition, where players were tasked with completing a level, and then based on the level, the data that was accumulated from the level, it would then generate more levels off the back of that. So it was essentially reading the data it read from the player, was parameterizing their generation systems.
So it's a nice little feedback loop there, that you get a recursive level generation. But with that, you'd be getting narrowing down, maybe? Would you start going towards entropy with that? Because you start getting hey, the previous level you did jump, forward, jump, and now I'm going to use that to develop the next level.
It's sort of like if you're, I guess what you're doing is in academic terms, you're reducing the overall parameter fitness space that you're trying to learn within. So if you imagine the space of all possible Mario levels you could ever make, and then based on that information you're getting, it's narrowing the scope quite drastically, because you're essentially trying to overfit the generator so that it generates stuff for you. That was very early phase research, and it's kind of continued, and it's still going today, actually. It's a kind of running gag at the procedural content generation workshop that runs at an academic conference. It runs at FDG this year, the Foundation of Digital Games in Malta. It's going to be running digitally, of course, given the circumstance. But generally, one of the things they have in the call for papers is games, PCG projects that are not made in Mario are strongly encouraged.
Wow, it's become a real trend.
Oh yeah, absolutely.
I mean, Mario has a lot to teach us about level design. It has. I guess it's easy. It's got some very interesting ways of teaching the player how to do things and when it breaks the rule. So it'll be interesting to see how some of those theories applied to other games that are not Mario. I saw one talk. I think it's a Crow team that did the Talos principle. They did testing of their levels using a game AI. So the game AI would run across a level and compare the images it took every few frames to how it should be before. So that was their unit test or their level testing. So they said, okay, right, we throw in a game AI, right, not like a full captured AI, but like an NPC to go and run across the level. It'll go to point A, point B, point C, and it takes a frame and said, okay, right, this should be this. And in your unit test, I say, okay, well, this bit's broken. So you'd go and highlight in the image where it's broken. And the next pass, it should be different from the original pass, for example. Which I thought was really interesting. Which is here you go. Here's an image where the things are wrong. Please fix it.
There's a slowly growing kind of body of work in that space of, can you actually use an AI player to minimize essentially the human work in QA.
Right.
Particularly functional elements, like more kind of aesthetic, qualitative things. That's something that only really a human can parse. There's some great stuff. Earlier this year, I actually did a collaboration. I actually got to work with Ubisoft and did a 3-video series on the AI of Tom Clancy's The Division and The Division 2. And one of the things that they do at Massive's the lead studio, but it's actually Ubisoft Leamington here in the UK that developed this particular tech. They have a series of bots that are dropped into levels and are able to now entirely, on native consoles or PC, play through entire missions in the game. And they record everything that happens. They record not just whether or not the level's working as intended, but even, what's the frame rate like right now? Did something happen? Did I interact with something and it didn't respond? So they collate all this information, because essentially, as a fan of that game myself, and as fun as it is, it's ultimately move into point A, shoot everybody, maybe interact with something, move to point B, shoot everything, interact with something.
Right.
So they figured out, and actually the level designers embed metadata into the level that is essentially markup for the AI to know what to do.
Oh, wow.
And that's part of the level design process where they say, okay, well, when you build this, actually add in all the features that will allow for a bot to walk into this area and know exactly what they're supposed to do and what the objective is at that point in time, so they can complete it in testing.
Yeah, a lot of times when you develop those kind of games, you have the player interaction and you have to also have the AI interaction. So when you're now playing and there's like the automated testing happening and there's like bots thrown in, the AI will be able to interact with that. Although that brings another set of bugs with that feature. It's not just, oh yeah, the bots magically find all the bugs. That system is also, basically, it's like magic. It's very hard to make that work and make sure that you're getting the right data too.
Yeah, it's, particularly for that, the Division situation, that was actually something that slowly matured over a period. So they actually have a team that's dedicated to making sure the bot bugs are or as low as possible. So they have just a team of people, I think, at Leamington who just look after the bots. But it started, they actually have a separate set of bots at Massive, which are server-side. And all they do is randomly teleport around the open world, shoot everything, and then clip through walls to the next location, and they just make sure that they could actually like move around and actually trigger in-world events just by going around teleporting and stuff. But the client bots, that actually emerged because during the development of the first Division, one of the expansions, the Underground, that procedurally generates underground tunnels, and so they didn't know during development how they could get QA to successfully test like 12,000 different permutations, and that was the solution. Was they started building this bot toolchain which then rolled out into the Division 2 as well.
I can imagine that would be really useful in development as well for a designer, especially if you're working on a squad-based game or something which is multiplayer. You can, rather than disrupting the work of half your team, you could just boot up an instance with some bots in, and they could play it with you if they were good enough, just so you could test something you'd put into the game.
You know, someone's going to be complaining about the aimbot, aren't you?
That's a bit different.
Yeah, I know. But if you got like your squad mates and they're like 100% accurate, and then you suddenly go into a network play, someone's going to complain.
That is an interesting thing, actually, making AI worse, intentionally crippling AI to make them not play so perfectly. What are your thoughts on that, Tommy?
Like, pretty much every game does it. I always find, like, I find it kind of hilarious that particularly the AAA video game industry is predicated on male-driven power fantasies of big burly dudes with guns running around shooting each other, and then the first thing we have to do on every design level is hobble the game so that these poor flesh bags could actually beat it. Because otherwise, if you actually let anybody who's played Arma 3 on like the highest level of their AI, the shot accuracy and what have you is godlike, and that's the first thing you have to do, is to start reducing their competence over time. And it's even, I see it a lot with a lot of other games, but be it Alien, be it Ghost Recon, or other games that I've looked at, where it's, we'll just make it that the character didn't see you there. We'll just make it that you're deliberately invisible when you hide behind this piece of cover. And this is usually something that comes out through iteration, through playtesting, and level designers saying, hey, can we add this feature in here that gives the designers more focus on that mood, that style, that experience they want players to have, versus what players think is actually happening.
But that's also, especially if you can see the AI who are intentionally fluffing the shot or doing the wrong thing, they've still got to work in a way that looks believably bad. So they can't just like sort of spin 180 degrees and fire in the completely wrong direction. They've got to be intelligently bad at playing.
Again, it comes back to this performance element.
The theatrics,
Yeah, exactly. It's like they look like they're doing something intelligent, and then when you get down to it, it's he's deliberately missing.
Wasn't it one of them? It was a Spec Ops The Line, when they're about to throw a grenade. There's a bark that comes from somewhere. It's not even from one of the people. It just goes like, oh, there they are. And a grenade spawns from somewhere, doesn't it?
So grenades don't actually get thrown, they get dropped. Spec Ops The Line's episode, hang on, I'm going to look this up because I have it in front of me. Episode 29 was Spec Ops The Line, when an animation is done to trigger the grenade throw, and then it just drops above your head.
Okay.
And it just lands at your feet. And they have the voice, it's like, oh god, grenade, throw a grenade at him. And then you're supposed to be like, oh god.
Yeah.
What other ones can I think of off the top of my head? Fear, whenever they do coordinating tactics, it isn't a coordinated tactic. One character decides they're going to do something, and then the game tells another character in proximity to say a line of dialogue to that character to tell them to do the thing they've already decided to do. So if a character goes to flank you, it just goes, it speaks to a parent system and says, I'm going to flank around this side of the map to the player. Is there another character near? Jeff's nearby, because these characters can't see each other. They'd have no acknowledgement that other NPCs exist in the map. Okay. And so it says, okay, could you tell him to tell me to flank?
Yeah. It works a lot like that in The Last of Us, doesn't it? Or at least that's what I'm observing. Like, they say, hey, I don't know, Jeff, like you said, go flank, the player. And they're like, oh, I'm on it. But they probably were going to do it. And then the other guy who's nearby, they make him say that line. I mean, I'm not sure if that's how it works, but it's definitely noticeable in those kind of games where AI talks to each other. Like, it looks like they talk to each other.
It's more or less exactly the same thing, because modeling and encoding like a multi-agent problem, that's essentially what that is. It's a multi-agent decision-making system. That's incredibly complex. It's so much easier in most cases to just have AI characters not know that one another exists, and then have some parent system that overlooks that and just kind of, it's sort of the drama manager. It's going, okay, you go over there, you go over there, you say this to this guy, you say this to that guy, and the player will come out of this thinking that this is all really tightly coordinated and well behaved. I think the other one's Far Cry. I think the more characters in proximity of you that are shooting at you, their accuracy and damage decreases.
Oh, really?
Oh, yeah.
Oh, wow.
So that happens to Stormtroopers as well. You put enough Stormtroopers together and they all just fire completely off target.
That's exactly it. It's the Stormtrooper effect. I think once it gets to like more than 2 or 3 of them, their accuracy begins to decrease and their damage decreases, because it's meant to allow for, if you get caught in a big firefight, there's a chance you can still get out of it.
This is the thing. Like, I was working on a game called The Hit, learning a little bit about AI. And I'm not going to say it was AI. It was literally a thing that just spotted you, and it would do a line trace, and if it hit you, you were dead, right? It's like, oh, you're dead. And this is the first time I was writing this, I've got to say. So I knew nothing about games. And of course, it would hit me every time, because the moment it saw me within the frame, I was dead. And as a player, I was like, well, how do I get around this? I have to make it like slow down the aim of the thing, and I would have to like say, okay, so the targeting would have to start somewhere else, and then I'd have to show the player that it was coming towards you. So I had to like slow it down, because my first pass just killed me every time.
And even like a lot of games, like stealth games in particular, it's very rare that when a character sees you, they actually acknowledge you at first. So like, typically you would use like a view cone or some similar system where it, in fact, Alien does this. So the Xenomorph has a view cone, and if you are in that view cone, it will wait a certain amount of time before that signal is strong enough that it then says, oh, I can actually see you now. And that's a couple of seconds.
Right, it's a kind of like an attention thing, right?
Yeah, so if you think about games like Splinter Cell or Far Cry does it as well, they often show you that progression. I think Dishonored does it as well. You see the progression of, it's like, oh, I'm almost seen, oh, I'm seen now. And that is literally visualizing an internal system that's saying, oh, you're within that character's view cone, but the threshold that says that you've been spotted hasn't been hit yet.
That's far more fun for the player as well, isn't it?
I think visualizing that is so great, because it gives you all this extra information about, oh, is this a good idea? And so much of good AI in games is not actually making it smart, but making it interpretable, that you can understand why that happened. Right? Because otherwise you're just sitting there like, oh god, it shot me again in the head for the 812th time and I don't know why it did it. So communicating that is really valuable.
Anyone who's played paintball on a team building day at a games company knows that people see you very, very quickly and shoot you very, very quickly, because you don't hang around, whereas it's not a fun experience being shot. So give the player a break.
You should do like a video game version of that where you're not allowed to shoot them until you've seen them for a second.
Oh, wow.
Oh, wow. You are the AI.
And they start crystallizing into existence. The Last of Us 2, and I can't remember The Last of Us 1. It's been a while since I played The Last of Us 1. They do this all with sound. So all the infected start making slightly different noises, and they increase in pitch until they attack. Which I know Valentina's been playing The Last of Us recently. And
yeah, so for the infected, as far as I know, you can hear different, for the clicker, they start like playing different animations, they start like clicking more, they start to be a bit more hectic. That's how they show that they are, oh, okay, I'm about to hear you, I'm about to see you. when it comes to human AI, what I have noticed is that, well, the main thing is the sound they're playing, instead of like a bar instead of on their head saying, hey, now you're being noticed. It's like this sound that increases.
It's like heartbeat, isn't it?
No, it's something else. I can't describe what it feels like. It's kind of scary, to be honest, because it's like, oh, I'm about to be seen. You can do it in many different ways. Dishonored has the icon above their heads, and it's filling up, and it can have different states too, right? It can be white icon, that means, oh, maybe I noticed something, but I don't know where the player is. Or it can be a yellow icon. It can be, I'm alerted now, I'm gonna go explore that area. And then the red icon could be, now I know exactly where you are, I'm about to attack. So there's many different AI states and intelligence, I guess, behind stealth AI specifically.
I assume it's getting harder as well. Would you say it's getting harder, Tommy, because you're reducing the abstraction and increasing the fidelity to a point where the enemies are no longer looking like sort of angular, but like the guards in Thief, for example. They can't see you when they're standing very close to you in a dimly lit corridor, but that's kind of accepted because that's fun. If they could see you like you could see them, it would not be a fun game. It would be a very different game. And I guess it's going to get harder and harder to make the player accept that that enemy can't see them. So either you're going to, what do you think you're going to have to do? Put the player further away, or give them more opportunities to like literally hide in grass and behind things and cover? What's the answer?
It's interesting because I've literally done recently, I accidentally created a season of stealth on the YouTube channel because I did Alien Isolation, Splinter Cell, Blacklist, and The Last of Us back to back, which was purely the show was crowdfunded over on Patreon, and that was, they voted for it. My patrons voted for those videos, so it just kind of happened by accident. But interestingly, across all three of them, all of them do the same things of having different types of view cones, which have different rates of activation, different style of view cones that allow for peripheral vision versus distant vision, even audio. The idea of if an audio event triggers, how do we do a very quick occlusion calculation so that we can ensure that, if you make a sound in this context, yeah, the character's definitely going to hear it. But if you're over in this, maybe if you're on the other side of a wall and you make that noise, then the character isn't going to hear it. And trying to build those systems so that they're flexible and they work from one level to another, for one character to another, in one scenario to another. It's really interesting because it's not a solved problem by any stretch. And it was really fun actually doing those three videos because none of them do it the same way. And they all have, there's a lot of commonalities, but the intricacies of the actual implementations are quite different to varying levels, and it's quite fun to see that.
When we talk about AI intelligence, how much do you think it's AI programming versus AI design? What influences the AI intelligence, a game designer or a programmer mostly?
It's a blend of the two, ultimately, because the programmer's there to build to actually do the low level work of actually building the behaviors, of ensuring the behaviors transition from one to another smoothly, often working with the animation team to then make sure that those behaviors are sold really well by the animations that are coming out of it. And it's interesting, a lot of the episodes I've done, particularly when I look at a lot of the larger AAA titles, how embedded programming and design teams are with one another. And so you'll often have there's an AI designer who's embedded in the programming team. There might be a level designer that temporarily works with them, and they share roles and they try and exchange information, because from one studio to another, either the programmers give the designers all the tools that they want and then say, okay, you can go and build whatever experience that you want to have, and then specifically if there's a particular feature you're looking for, or maybe the characters don't do this particular thing in this situation the way you like, let us know and we'll enrich those tools for you. And then other times it's the programmers do all of it and the designers are then just allowed to play with those toys and figure out interesting ways of playing with the toys. So there's different levels of kind of relationship, I think, between programming and design teams.
Are there any games that are a good example for that kind of distinction?
So certainly for the first one, the Division was actually a really good example of that. So I know for a fact that they have designers and programmers work together quite heavily, but there's the AI combat design team is separate from the level design team. But the level design and combat design teams frequently talk to each other. They have people come and work with their respective teams for periods at a time. And then the programmers, they're working with the designers around them to help facilitate what they want. If I remember correctly, Doom 2016, almost all the behavior stuff is handled at programming level. And then the designers essentially just ping feature requests at the programmers whenever they want. I think it's down to the differences in the tools and the architecture that they have. And certainly it seemed like The Division was a good case where they were really focused. Actually, there's a very good GDC talk about this, about the hiccups they had in building the design tools so that the programmers didn't have to get involved. And it just allowed the designers to do what they wanted to do. And only when things were really falling apart, they say, right, we need to go and talk to the programmers. Something's not right here.
Was this where they had these massive behavior trees that literally look like neural networks, I think? I don't know, like the neurons in your brain. I think you showed in one of your videos that it was like this massive... I mean, when I say spaghetti, this is on a whole other level.
It was terrifying. I know the one you're talking about.
And you spaghetti monster.
Yeah, they could run it and see the behavior within the behavior tree, or the nodes being lit up in the behavior tree. But I was like looking at it, going like, how do you know what's happening?
How do you debug that? That's the thing that scares me.
It's actually very interesting you mentioned those two games. So The Division, when you play it feels a bit... Well, the AI obviously has its own intelligence, but it feels more designer-centric. So, hey, make this guy now go behind that car, and maybe hey, have this guy with a, I don't know, bazooka over somewhere, making sure that he's shooting you. Whereas Doom is more of an arena. You have the enemies there, and they do their own thing. They don't have like specific design. Hey, now go hide behind the cover and only come out when the player hits this trigger. There's no such thing in Doom, right? They don't need designers to specify smaller interactions like that, like you would find a Division or other games that
it's that toy box distinction, I guess. Like Doom feels like a toy box where, okay, we're gonna have this, and they're gonna have this particular setup where we're gonna have a couple of imps, a Hell Knight, maybe a Baron of Hell, a couple of Caco Demons, but we'll stage when they come in based on how many characters have been defeated. And I guess it is like you said, like the Division's a nice example because it's very curated. How they want a particular sequence to turn out during a mission, whereas Doom, it's sort of right, but we kind of want it to go a bit nuts, we kind of want it to be a bit crazy, and we can kind of rely on the AI to an extent. I mean, there's still a lot of interesting work that happens on a design side because they have to do appropriate markup of cover spaces and everything, because the characters in Doom calculate the inverse cover in the environment. They literally take it's the same cover system they used in Rage, if I remember right, and then they just invert the output. So instead of telling me all the nice places to be that are in cover, tell me all the places that are out in the open, because demons don't hide in cover, and we want the player to be able to see us so that the player runs towards us. It's all part of that kind of push forward combat philosophy that they used in that game.
I mean, out of the scope of this podcast, but it's a very interesting reversal of all current game trends. I say all, like most current game trends of like the shoot and recover. This was more like, no, buddy. If you got low health, you run in shouting Leroy Jenkins and hope for the best.
And it is almost like a sort of dance that the player and the AI are doing together to make it fun, in a way, isn't it? Because I guess every single system and the player is trying to make a fun experience, and so the AI is following or breaking the rules in ways that get the player to have an enjoyable time, I guess.
Yeah, it's that kind of that balletic performance. Again, it all comes down to dramatic theatre. Can you reinforce this idea that this thing is happening and that the player is part of it? Like, I always think the funniest one is whenever you look at most combat systems in a lot of 3D third-person games like Batman Arkham or Assassin's Creed or what have you. Okay, move into an interesting location relative to the player. Okay, now just stand there and wait very patiently until you're allowed to punch him, even though there's 12 of you surrounding him.
Right, not bundle, you know?
Yeah, it's like, right, there's Batman. If we all just jump on him, we'll get him.
No, let's wait.
But no, we'll all kind of circle around him like, oh, I'm going to get ya, you know, sort of thing.
I think even God of War has that, doesn't it? The latest God of War, when you combat, not every monster is attacking at the same time. Otherwise, you'd get killed so easily.
I'm pretty sure even Last of Us does it as well. If you're engaged in a takedown, aren't you? Then everyone else basically fades into the background and ignores you.
I would say it's even worse there because it's very noticeable with The Last of Us 2 melee, where you start mailing one person and the other one stands next to them and just waits until you're done, and you can see them. You can just see them standing.
You finish killing Bob. Yeah.
Okay. Now you can kill me.
Are you done? Yeah. So it is very noticeable once you start like playing those combat games that they have this kind of waiting. But otherwise, it would be boring and it would be frustrating if everybody attacked you at the same time.
Right, so like at the moment that you're playing the kill animation, then suddenly the rest of the bad guys like bundle on you instead of beating you up. You'll be like, wait, no. I love the bit that in Arkham Asylum, maybe, that if you sneak up behind them, they won't ever turn around. So you can be sneaking up behind somebody, you know, like as Batman, and then you're about to take them down. They're never going to turn around because otherwise they'll be like, you know, why you crouch behind me, Mr. Batman?
So, Tommy, did you study anything about this specific thing that Mark is mentioning? Like when it comes to stealth and you're crouching behind an enemy, what is the AI doing there? Because they don't always turn around, right? In a lot of games, they just kind of wait a little bit. That's what I've noticed by playing. I'm not sure how the systems actually work, though.
Yeah, like a lot of the time, Batman, actually, I know that what that does is it generates like kind of patrol paths for them to follow, and deliberately trying to build something that will allow them to essentially achieve cycles within the space, but because they want to minimize backtracking, because the idea is meant to be that, you know, it's not going to look great if Batman gets caught sneaking up behind someone, so the characters will avoid doing a 180 at all costs. Like a 90-degree turn, that's fine, but 180, it'll try and minimize it.
And that's only like if they like hit a dead end, probably.
Yeah, but you'll notice how most of the stealth sequences take place in big open spaces that very rarely create dead ends.
That's really interesting, actually. Yeah, we when we were doing Silent Hill Shattered Memories, we had these chase sequences, and they had AI agents that would run through there and chase you. And we were running into problems where the player would get caught in a dead end, or basically the environments we were trying to make were quite realistic, but they just didn't work with the gameplay. So eventually we made all those levels into effectively deathmatch levels with very high connectivity and very looping topographies, so that you would always have a kind of out and a way to carry on and avoid things. And it was just completely interesting how that was the way to do it.
And it also creates routes for the players to memorize, I guess, if the characters are moving through those spaces. One of the funniest ones about The Last of Us is if you ever watch the clickers, the vast majority of the clickers move on fixed patrol paths, which is weird if given they're blind, but they seem to have a very acute knowledge of where they're going. Not all of them do. Some of them move randomly, but again, they actually retain a memory of where they've went, so they don't backtrack on themselves. And there's an edge case in it where if you throw a brick somewhere and attract a clicker to a sound, and it pulls it far enough away from its original patrol path, it will only then move randomly afterwards, because it's going to look really obvious when that blind character returns to that exact same patrol route that it was on 2 minutes ago.
Like, oh, sorry, I was going. Yeah, I was going around.
Hang on, I need to. Where's my stage position again? Yes, let me go back over here.
No, that's very true. I've noticed that about the clickers, that especially if you like throw a firebomb at them, they get very confused and run around, and then like they stand around shouting at walls. But at least you don't get them bumping into walls embarrassingly, which I thought they would do being blind. But
I read in a book, was it Game AI Pro Volume 2, which is a lot of the chapters in that, which are free to download, by the way, if you're listening. Great place. Game AI Pro is really good to read into about kind of the inner workings of AI in a lot of AAA games. The chapter dedicated to the infected, they talk about how they originally built an echolocation system into the clickers so that they would bark and actually build their own internal map structures.
Oh my God.
As if they were like bats. And they had a working prototype of this, and they shelved it because essentially every playtester was completely befuddled, because the character, this clicker would bark in the direction of the player, immediately then see the player and then kill them. And players in testing couldn't understand how echolocation was working, and like, hang on, it's blind, how did it see me? And so they scrapped it and then went for the admittedly simpler approach.
Yeah, I think they only mentioned that they have echolocation, but it just listens to the player's movements and where you throw bricks or bottles. It doesn't actually bounce off the walls and does that elaborate thing. Yeah,
it's all an illusion again, isn't it? Those damn programmers.
Faking it so we can make it.
Absolutely.
Tommy, it's been an absolute pleasure to have you on the show this time. We will have to have you back on when I've played the Division 2 a little bit more, so I can ask you proper questions rather than like my superficial knowledge of the Division 2, because I know you've gone into a hell of a depth.
I feel bad now because I know you want to ask Alien Isolation questions.
I know. So, but we'll dedicate like a whole show to that, I think, and just go like, look, we're going all in. We're going to get as many people that know Alien Isolation, and we're just going to thrash it out. Damn it. But on that note, if people want to find out more, where should they go to?
So check out AI in Games on YouTube. There's quite a lot of stuff there. If you're ever interested in trying to get more of an understanding of how AI is built in AAA video games, but also how AI research utilizes video games to improve the state of the art, that's pretty much what the channel's all about. You can also find me at aiingames.com. Where I do written versions of the videos, but also I talk about some of the work that I do with companies because I work as a consultant in this space. Follow me on Twitter at AI in Games.
Awesome. Thank you very much. And thanks, everybody. And that's it on the show.
Bye, everybody.
See you next time.
Bye everyone.
Bye. The Level Design Podcast has been a Command Studio production. Our editor is Matthew Lever, and this episode has been produced by Brian Lever.